This is the screencast for section 2.8, example 4. We're just going to look at a couple of polynomial inequalities with unusual answers. So this polynomial f of x, which is x squared plus 7x times 2x squared plus 1, so a fourth degree polynomial, graphs to be like this. Now as you can see, there are no real zeros, so this graph will never hit the x-axis. It will also never go below the x-axis. So we can say that the solution of values that make the function greater than 0 is all real numbers. Same with greater than or equal to 0, as you can see from these two. However, the solution set where this function is less than 0 or less than or equal to 0 is what we call empty. There are no x values that would produce a negative y value or a y value of 0. Now in part B, it's a very similar situation, except we do have a 0, just one. So the solution set that will produce values greater than 0 isn't all real numbers anymore. It's all real numbers except for negative 5 halves. So they wrote that like this: negative infinity to 5 halves, not including it, because negative 5 halves makes the function equal to 0. We only want greater than. Then from negative 5 halves to infinity, those x values will also produce a positive or y value greater than 0. The solution set, Java update. Okay, the solution set that will make the function greater than or equal to 0 is all of them, because every x value will make the function either greater than 0 or equal to 0. Now, as far as less than 0, that's still an empty set. The solution set that will make the function less than or equal to 0, still no less thans. No x values will make the y value less than 0, but one value, negative 5 halves, will make it equal to 0. So therefore, that is a single number, x equals negative 5 halves. So I took it upon myself to graph example 21, the now try problem, and we're going to answer parts A, B, C, and D. So for part A, where f of x is greater than 0, that's all real numbers. Every single x number I plug in is going to produce a y value greater than 0. So that's negative infinity to infinity. Part B, where is the function greater than or equal to 0? Well, it isn't actually equal to 0, but it is greater than everywhere, so that's still negative infinity to infinity. Then part C, where is this function less than 0? That set is empty. Where is the function less than or equal to 0? Well, it's never equal to 0, and we already established that it's never less than 0, so that set is also empty. Had the vertex of this parabola hit the x-axis, there would have been one value, 0, where the function did equal 0, but not the case here.